Okay, so now we move on to the next part of our lesson, straight lines. Okay, so when it comes to straight lines, we have discussed about straight lines in P4. In P4, the equation, the parametric equation of the vector equation of a straight line was given in the format R equals A plus lambda B. So what does this represent? A represents a position vector on the line, right? A represents the position vector on the line, while the B represents what? The direction vector of your line. Okay, so A is an actual vector who is on your line. So we say point capital A. I can say it like this. Point capital A, the position vector of OA is equal to A. We'll say it like this. Okay, and then this straight line is parallel to vector B. It's going in the direction of vector B. So then what we do is we take a general point, take any general point on your straight line. So any general point on the straight line, I'll name it as R. Any general point on the straight line, I'll name it as R. So then what do we do here? So what we do here is I will write the vector AR. How do we write AR? Shall we define it in terms of the origin? So you know from origin to A, the vector is A, and from origin to R represents what? Any point who is on the line. Let's say OR is vector R. So I'm saying OR is vector R. Okay, how do we write the vector AR? AR is a direction vector, right? So how do I go from A to R? We can go from A to O. I mean, basically R minus A, right? A to O, O to R means minus OA plus OR. Or basically R minus A. That's how we write it, isn't it? AR vector is R minus A. Okay, so now, do you remember in the very beginning of this lesson, I was telling, I was defining you something special feature about the cross product. Cross product of what vectors becomes 0? The cross product of parallel or perpendicular vectors becomes 0. The cross product of parallel vectors becomes 0. If two vectors are parallel, then the cross product of those two parallel vectors becomes 0. Thereby, what happens here? Do you see AR is actually parallel to a certain vector here? AR is parallel to whom? The vector B. So, because AR is also giving a direction of the direction vector on the line, while B is also giving the direction of the line. Therefore, what do we say here? AR vector, if you take the cross product with B, it should give you what? 0. Because the cross product of two parallel vectors is equal to 0. So you can write like this. Since AR is parallel to B, since AR is parallel to B, AR cross B equals to 0. So who is AR? AR is R minus A cross B is equal to 0. Okay, so this is the main equation that we use for the cross product. So this is the main equation that we use. By using the cross product, we are actually defining the vector equation of a line. Okay, so this equation we can further simplify it and open the bracket and write it down as, you can see we can open it up, R cross B minus A cross B equals 0. And then I can take the minus A cross B to the other side as plus A cross B. So this is another format to give the equation of a straight line. R cross B equal A cross B is also one method of giving a straight line, while R minus A cross B is also another alternative way of giving a straight line. So both of these are used. More widely, we use the first one. R minus A cross B equals 0. So the moment you see it, you know it's a straight line, and you know the first person here inside the bracket, A is a position vector on the line and B is the direction vector on the line. So it's extremely important that you identify that A is a position vector on the line and B is the direction vector. Exercise 5D, question number 1, they say find an equation of the straight line passing through the point with position vector A, which is parallel to the vector B, giving your answer in the form R cross B equals C, where C is a vector to be found for the following pairs A and B. Okay, so you can see they've given you in which form. I gave you two forms for the straight line, right? What are the two forms? R minus A cross B and R cross B equal A cross B. Now, which format do you think they are asking you to give me? They are saying give your answer in the form R cross B equals C. So what does that form mean? It means it should be R cross B equals A cross B, because this C here should represent the A cross B. Now you know how to get the cross product, right? Okay, so then they've given you A and B. Can't you get the cross product? Get A cross B. A cross B is get IJK. We get the determinant of a 3 by 3 matrix. So A is 2, 1, 2. B is 3, 1, minus 2. Cross product gives me plus, minus, plus. I times, I get here 1, 1, 2, minus 2. Minus j times 2, 3, 2, minus 2. Basically, ignore the row and column with the particular vector here, plus k times, ignoring the row and column with k. I get 2, 3, 1, 1. Minus 2, minus 2, minus j times, minus 4, minus 6, plus k times 2, minus 3. So I get here minus 4i plus 10j minus k. A cross B. So now give the answer. So the straight line equation is R cross B equal A cross B. So do we know the B value? Yes. So R cross B is 3i plus j minus 2k equal A cross B is minus 4i plus 10j minus k. Or you could give your answer even in column vector form. R cross 3, 1, minus 2 equal minus 4, 10, minus 1. You would even give your answer in this form. Okay, so now we'll go to the next part, Cartesian equation of a straight line. Okay, so now we learned how to find the vector equation of a straight line. Right? We wrote the equation of a straight line by using the cross product, R minus A cross B equals 0, or we could use R cross B equal A cross B. So now I want you all to learn how to convert this vector equation into a Cartesian equation. So Cartesian equation means what? Basically, an equation with what? With x, y, and z. Okay, so that's the Cartesian equation. So they will go through this example. They say here, a line has vector equation r minus, of course, you can, when you see this, you know it's r minus a cross b, right? A line has vector equation r minus a cross b equals 0. Show that the Cartesian equation of the line can be written as x minus 1 over L equals y minus 2 over m equals z plus 1 over n, where L, m, and n are integers to be found. So they're asking you to find the values of L, m, n, and you can see here this is a Cartesian equation. Why do I say it's a Cartesian equation? Because the I mean, you can see it's in terms of x, y, and z, right? You don't have any r here. You don't have r. You've gotten rid of the vector part, and you have got it in terms of Cartesian coordinates. Okay, how do we do this? First thing we'll do is let's r here is an unknown term, right? So r minus 1, 2, minus 1 cross product with 4 minus 3, 2. So r is a general coordinate on your straight line, isn't it? R can be, R represents any general point on your straight line. So I will say that R be what? X, Y, Z, because it has to be a general point. R should be general. So I'll use R as X, Y, Z minus, this is what? 1, 2, minus 1, right? The cross product of that with 4 minus 3, 2. Do you follow me? I'm just writing this equation again, replacing R as X, Y, Z. Okay, so then let's get the answer here. X minus 1. Get the answer for the first product. X minus 1 over y minus 2 into z minus is z plus 1. Cross 4 minus 3, 2 equals to 0. So this is actually, you can see this is in the form r minus a cross b equals 0, right? I mean, you can see it's given in this first format. Do you see? R minus a cross b equals 0 format it's given. So we are going to learn how to convert that to Cartesian. So what do we know if, now you can see here I have two vectors and the cross product of these two vectors becomes equal to what? 0. So when the cross product of two vectors become equal to 0, what do we understand? These two vectors are parallel, isn't it? If the cross product of the two vectors become equal to 0, the two vectors are parallel, which means x minus 1i, I'll write it in the normal form, y minus 2j, z plus 1k is parallel, isn't it? To 4i minus 3j plus 2k. How do we normally get rid of the parallel sign? We input a constant. Yeah, let's input a constant some lambda. Don't put k because k is already our the unit vector of z. Okay, so I'll put here to equate the to remove the parallel sign. I'll put a lambda here. Lambda times 4i minus 3j plus 2k. So now we can what? Since these two sides are equal, I can compare the coefficients. So let's compare coefficients. What do we get? I when you compare, we get x minus 1 equals 4 lambda. Do you agree with me? J vector we get y minus 2 equals on the other side minus 3 lambda. For k we get z plus 1 equals 2 lambda. So now what do we do? Now you can see all these three equations have a common person called lambda. So finding lambda in each of these equations, we can actually equate all three of them together. So when I make lambda the subject from the first equation, what do I get? X minus 1 over 4. This is equal to lambda. From the other equation, if I make lambda the subject, what do I get? Y minus 2 over minus 3. And from the other equation, if I make lambda the subject, I get z plus 1 over 2. So all of these are equal to lambda. Each and every one of these pair is equal to lambda. Do you see? So this, do you see that I have got a Cartesian equation here because I have got it in terms of x, y, z. And you can see the bottom we have the 4 minus 3, 2. And at the top I have these numbers. Now look at these numbers again. So these numbers are a little bit special. Look at 4 minus 3, 2 in your original sum. Do you look at 4 minus 3, 2 in a certain place? Who is 4 minus 3, 2? Now you know this format here is r minus a cross b, right? Equals 0. It's in that format. Do you see here? 4 minus 3, 2 are the coefficients of your direction vector. Okay, and what about the top? Minus, we get here 1. So you can see here we have 1, here you have 2, and here with the plus mark you have another 1. Do you see something like that? You have similarly something like that over here, 1, 2, minus 1. So do you see here x1, you have the 2 here, but here we need a minus 1. Now you can see in all of these, we have a negative sign in the middle. Yeah, so I could write here z minus 1. Just to show you how this works. Z minus, this is minus 1. Just to show you that these values, now look. So these values I've gotten from where? I got it from the position vector. 1, 2, minus 1, I'm getting it from the position vector. While 4 minus 3, 2, I'm getting it from the direction vector. And this is called what? This is called what? This is called the Cartesian equation of a straight line. So it's written in totally in terms of x, y, and z. So let me give you a general format for this. So if I have an equation r minus, say our question vector is a1, a2, a3, r minus a cross b, right? So b, let's say it's b1, b2, b3. You don't need to go through all of this. You can directly write the Cartesian equation. How do we directly write the Cartesian equation from the vector equation? Use this format: x minus a1 over b1 equals y minus a2 over b2 equals z minus a3 over b3 equals to not 0, equals to lambda. Okay, so this is the method of converting. This is how we convert a vector equation into a Cartesian equation. So coming back to exercise 5D, question number 2. They say here find a Cartesian equation for each of the lines given in question 1. So I'll do the first line given in question 1. We already found the cross product of it. I mean, we found the vector equation by using the cross product. So this time we are going to find the Cartesian equation for this first part. How do we do it? So the equation is x minus, just input the a coefficient. What are the a coefficients? X minus 2 over the I coefficient of the direction vector over 3 equals y minus the j coefficient is 1 divided by the j coefficient of the direction vector is also 1 equals z minus 2 over minus 2 equals to lambda. So this is the Cartesian equation. Question number 3, they say find in the form r minus a cross b equals 0 an equation of the straight line passing through the points with coordinates 1, 3, 5, 6, 4, 2. So in here, again, this is quite similar to, I mean, a little bit similar to what you've done in 2T4 because you have a straight line passing through 2 given points. Now, the thing is, what do you need here? There's a straight line passing through 2 given points. Let's say it's C and D. So they've given you the point CD. How do we find the equation of the line in the form r minus a cross b? Basically, a is what? A position vector on the line, while b is a direction vector. So don't we have a position vector on the line? Don't we have a position vector? Both are position vector. Both 1, 3, 5, 6, 4, 2 are position vector. You could use any one of them for A. And what do we use for B? What do we use for B? We could use the, I mean, what's the direction vector of the line? We could use CD or you could use DC. Any of the two is fine. Any multiple. I mean, CD or DC. So I'll go with CD. Okay, so B is a direction vector of the line. So for A, I will use the C coordinate, which is 1, 3, 5. And for B, I'll have to get the CD vector, right? So CD vector is D minus A. Get the D minus A. D is, you realize what I use for CD here, right? For C, I use the coordinate 1, 3, 5. For D, I'm using the coordinate 6, 4, 2. Are you okay with that? So D minus A, D is 6, 4, 2 minus A is 1, 3, 5. So 6 minus 1 is 5, 4 minus 3 is 1, 2 minus 5 is. So this is the vector B. Now can't you fill it in the vector form? Just write it, fill it r minus a cross b equals 0. Are you with me? So input the value. R minus, who is a 1, 3, 5 cross b equals 0. That's all they need to see here. Just to give it in the form r minus a cross b. Okay. Question number 6, find the equation of the straight line with Cartesian equation x minus 3 over 2, y plus 1 over 5 equal 2z minus 3 over 3. In the form r cross b equals z. Okay, before you go into anything else, you need to first find, I mean, looking at the Cartesian form, I told you could get the A and B. A and B means what? A is a position vector on the line, while B is the direction vector on the line. Now you saw when we got this particular format, when I was doing the proof, did I by any chance get 2z or 3z or any coefficient with any of these x, y, z values? No. So it needs to be alone in order to get the proper direction vector, position vector and direction vector. So how do we fix it here? How do we fix the 2z here? How do we fix the 2z here? Because you need to fix it like you have to fix it in such a way that there's no difference to the sum. So how do I get rid of the 2 in front of the z? So then to get rid of the 2 here, what we do here is we divide both up and down by 2. Basically, or you can say you multiply by what? Dividing by 2 is the same as multiplying by half. Say you multiply both up and down by half. So what do we get here then? 2z into half is z. Minus 3 into half is minus 3 over 2 divided by 3 into half is 3 over 2. So this is the format I prefer to keep it because in this case I can see my position vectors clearly and I can see my direction vectors clearly. Okay, so keep it like this. Now let's write our a values and the direction vector coordinates and the position vector coordinates. So then I get here my A coordinate. So what's the position vector coordinates? X minus 3. When you have x minus 3 directly, the position vector I coefficient is directly 3, right? Do you remember in the middle we need to see a minus mark here. Y plus 1 means what's the coordinate here? This should be minus 1, isn't it? Because we need to have in the middle a minus. So we write y minus minus 1, which means is minus 1. Z minus 3 over 2 means the other coordinate, z coordinate is 3 over 2. Do you agree with me? And what about B? B is 2, 5 and 3 over 2. So this is your A and B. So now all you need to do is to give it in the form R cross B equals C means what actually? R cross B equals to A cross B. R cross B equal A cross B. So now get the A cross B. So A cross B answer, let's find it. A cross B, so we'll use I, J, K. 3 minus 1, 3 over 2. 2, 5, 3 over 2. So we'll go plus minus plus. So when I use the cross product here, I get I times, so shall we directly use? Minus 1 into 3 over 2 is minus 3 over 2. Minus 5 into 3 over 2 is minus 15 over 2. Minus j times 3 into 3 over 2 is 9 over 2. 2 into 3 over 2 is 6 over 2. Plus k times 3 times 5 is 15. Minus 2 into minus 1 is minus 2. How much do we get here? Minus 9i. Then minus 3 over 2j and here 17k. So basically R cross B equals A cross B. So R cross B is 2y plus 5j plus 3 over 2k equals minus 9i minus 3 over 2j plus 17k. Either you could give it like this or you could write in the column vector form. Okay.